One day the sun will get so hot it'll boil Earth's ocean and wipe out all life. But the scary part is the sun has already changed a lot since it was born, and it's still changing right now. This is the full story of sun's past, 4.6 billion years of violent birth, dramatic changes, and a destiny written in nuclear fire. Before the sun, there was nothing but gas, dust, and silence. Around 4.6 billion years ago, a nearby supernova exploded, sending shockwaves through a giant molecular cloud in our Milky Way. This explosion didn't destroy, it sparked creation. The shockwaves compressed the part of the cloud, triggering the collapse of a region dense in hydrogen and helium. Then the gravity took over, pulling more and more material inward. At the heart of this chaos, a protostar was born. This was the sun's first form, not yet a true star, but a dense, spinning ball of gas growing hotter day by day. The surrounding dust began clumping into planets, including one tiny blue rock that would one day hold life. But back then, everything was still just beginning. At around 100,000 years old, the sun entered its T Tauri phase, a turbulent, violent toddler of a star. It pulsed, flared, and released massive stellar winds that blasted over leftover gas and dust from the solar system. It was spinning fast, incredibly fast, and injecting matter into space like a flamethrower on overdrive. This stage lasted about 10 million years. During this time, the sun wasn't stable. It wasn't even shining due to fusion yet, but it was getting close. Deep inside, pressure and temperature were rising, and finally at around 10 million years old, the core reached a critical point. Boom! The temperature crossed 10 million Kelvin. That's 10 million times hotter than boiling water. At that point, hydrogen atoms began slamming into each other and fusion into helium. This released enormous energy and marked the official birth of a main sequence star. Our sun was finally alive. This nuclear fusion has powered it ever since for over 4.5 billion years and will continue for billions more. But don't be fooled by its calm glow. The sun has not stayed the same. Believe it or not, the early sun was only 70% as bright as it is today. This created a problem scientists call the faint young sun paradox. Now, how did the Earth not freeze solid? Because the Earth's atmosphere back then was rich in greenhouse gases like methane and carbon dioxide, trapping heat like a cosmic blanket. Meanwhile, the sun's magnetic field was wild. Flares and coronal mass ejection happened more frequently. The young Earth was constantly bombarded, shaping its magnetic field, atmosphere, and possibly even life. Over the next billions of years, the sun slowly increased in brightness, and that growth still continues. And here is the mind-blowing part. The sun's brightness increases by about 10% every 1.1 billion years. That might sound small, but the consequences are massive. Over time, the Earth's temperature has gradually risen. More sunlight means more evaporation, more greenhouse gases, and eventually it will lead to climate instability. In about 1.5 billion years, the sun will be too hot for complex life on Earth. The oceans will boil, the air will be thickened, Earth will become unrecognizable. This is not science fiction, this is hard physics, but it gets worse. At around 5 billion years old, the sun will start running low on hydrogen. When that happens, gravity will crush the core while the outer layers expand massively. This is the beginning of the red giant phase. The sun will swell up to over 100 times its current size. Mercury gone, Venus vaporized, Earth may be swallowed or maybe scorched to ash. The sun's color will shift to deep orange or red. It will become cooler on the surface but hotter at the core. It will start fusing helium into carbon, throwing off outer layers into huge pulses. And at the end, the sun will shed its outer layers, creating a breathtaking planetary nebula. And what's left behind is the core, a super dense, Earth-sized object called a white dwarf. This white dwarf will glow faintly for trillions of years, slowly cooling, fading until it becomes cold. Black corpse, a black dwarf, a silent grave in a dead universe. The story of the sun isn't just a cosmic history, it's our story. Every atom in our body was forged by ancient stars. Every breath, every sunrise, every heartbeat comes from energy that began in the sun's core. Understanding the sun is understanding ourselves and our future. We orbit a ticking clock of nuclear fire, and it's both beautiful and terrifying. But here's something you probably didn't know. Despite how important the sun is, it's just one type of star among billions, a very specific kind called a G-type main sequence star, also known as a yellow dwarf. But why? What makes our sun fall into that category? And how rare or common are all stars like it? To find out, watch our next episode, Why the Sun is classified as a G-type main sequence star. Click it now or you'll miss one of the most eye-opening facts about our universe. And I'll meet you in the next video.